Hi everyone. So today we're going to continue with factoring. Nothing new. We're going to take notes today and they're going to help us recognize, because the hardest thing to do is recognizing which factoring methods we're going to use. So take a second, look at number 1, 2, and 3. Which factoring methods are those? Is it a GCF? Is it a multiply combine chart? Or is it dots? So I actually put them in order, right? Number 1, there's x's everywhere. That's a GCF problem. Number 2, it starts with an x squared, 3 terms. That's your MC. And number 4, that's perfect squares. So now pause the video and factor all 3 of them. All right, so number 1, we have a GCF here. What goes into 42 and 35? That's a 7. And then x cubed, x to the 8th, we just pick our smaller exponent, x to the 3rd. We divide and we get 5. Nope, just kidding. 6 minus 5x to the 5th. Remember, we subtract our exponents, parentheses, GCF on the outside. Number 2, we are multiplying to negative 50. Combining to 23. So that's 2 and 25. Now, who's going to be negative? Because we're multiplying to a negative, combining to a positive. The 2 is negative to give us a positive 23. If the 25 was negative, then the 23 would be negative. So x minus 2, x plus 25. And then last, that's a dot. So those are perfect squares and subtraction. So 1 plus, because 1 times 1 is 1. What times itself is 49x to the 2nd? 7x and 7x. And we are done. Okay, so what are those 4 factoring methods? I mentioned the first 3, right? So that's our GCF, our multiply combine chart, dots. What's that last one that we talked about? That is factoring completely. All right, so our first one is GCF. So think about, how do you recognize a GCF? What are some stuff that helps us? So one of the tough things is it can be both a binomial, binomial with a plus. Remember when you have perfect squares, it's always a minus. So if you have a binomial with a plus in it, there's the only way to factor it would be with a GCF. A trinomial with a number in front of x squared. So all the multiply combine problems, you're not allowed to have a number in front of x squared. There's x's everywhere. That's just a good rule of thumb. If you see an x in every single term, then there's going to be a GCF. And the big one is just you can divide. So the first thing I always do when I'm looking to factor, I look, can I divide by anything? So here's an example. So when I look 4x squared and 10x, I can divide by 2. So automatically, I have a common term that I can divide by. There's also x's everywhere, x squared and x. So there's lots of reasons why that's a GCF problem. All right, so next is our multiply combine chart. So I said in the last one, what must be true for that one? It has to be a trinomial. We only use the MC chart when we have 3 terms. And that highest term has to be an x squared. X squared doesn't have a coefficient. So you're not allowed to have a number in front of x squared to use your multiply combine chart. And then lastly, and this is the best way to check, it has to look like x squared plus bx plus c, where b and c are numbers, right? B and c are integers. They can be negative, but they're numbers. So it's always x squared plus something x plus something. Or minus, right? We can have minuses also. So for example, x squared minus 3x minus 4. So in this case, my b is -3 and my c is -4. Right. Third one is our dots. Now, dots is almost the easiest because it's very specific. There's no real questions. GCF and MC chart, like sometimes it works, sometimes it doesn't. This one has very specific rules for it, so I think it's the easiest. It has to be a binomial 100% of the time. It has to have subtraction in it 100% of the time. And it has to have perfect squares, and that's including x squared. If you had something such as 4x minus 9, that's not, the x is not a perfect square, so that doesn't work. I think that's what I put for my actual example. Let's see what I put. Oh, I did 9x squared. So in this case, because it had the x squared, it's a dots problem. Without the x squared, it's not a dots problem. And then lastly is completely. Now, completely is where it always starts with a GCF. Remember that. So it can be a trinomial or binomial, just like regular GCF. It always has a GCF. And then after taking out the GCF, you can do MC or dots. So that's where you factor the GCF, and then you have to look at what's left, and there's still a multiply, combine, or a dots left over. So for example, if I divide out that 2, right, if I divide 2 out, I get x squared minus 4x plus 3. That's my GCF. And then I have an MC chart after that. Right, so 2, what multiplies to 3 combines to negative 1. Minus 1 minus 3. So we did a GCF and then an MC. All right, so now here's some examples. So I want you to pause the video, write these down, and I want you to write down next to them which method is it. Is it GCF, MC, or dots? There is no factor completely in here. All right, so number 1, 3 terms with an x squared, that's MC. No, nothing in front of x squared. Number 2, 2 terms with a plus, that has to be GCF. Number 3, 2 terms, binomial, subtraction, and perfect squares. That's your dots. Number 4, trinomial, 3 terms with an x squared. That's your MC again. Number 5, x is everywhere. Even though 9 is a perfect square, x is everywhere. That takes over. And then lastly, x squared minus 1, subtraction, binomial, perfect squares, dots. Okay, so now that we've identified them, go through and factor them. So that's actually, we're going to go through and factor them. All right, so pause the video and factor. GC, nope, just kidding, MC. So MC, what multiplies to negative 60, combines to 7. So let's see, 2 times 30, 3 times 20, 4 times 15, 5 times 12. It's 5 times 12 because one of them's negative. So we get x minus 5, x plus 12. Number 2 was a GCF. What can we divide by? There's x's everywhere. Divide by x. We're left with x plus 7, parentheses, x on the outside. Number 3, that was our dots. Dots are perfect squares, right? Difference of 2 squares. So what's the square root of 100? What times itself is 100? 10 times 10. What multiplies to 3x squared? 3x and 3x. One's a plus, one's a minus. Back to multiply, combine. We're multiplying to 22, combining to negative 13. The only thing, this one's pretty easy. The only thing that multiplies to 22 is 1 and 22 and 2 and 11. 2 and 11 gives us 13, but we want it to be negative 13, so what do? Change the signs. So x minus 2, x minus 11. Number 5, that back to our GCF again. what can we divide by? 9, 9, and then you always take your smaller x. 4 is a smaller exponent than 7. So we divide. What's 9x to the 4th divided by 9x to the 4th? A lot of kids say it cancels out, but it cancels out, but what's it cancel to? Think about 9 divided by 9. 9 divided by 9 is 1. So 1 minus 3x to the 3rd. Parentheses, GCF on the outside. And then lastly, this was a dots, perfect squares. It's kind of a weird one. It's so simple, it's confusing. What times itself is x squared? X and x. What times itself is 1? 1 and 1, plus and minus. And that's our lesson. So we've gone through. Now you just have to practice. Like, I can't, at this point, I've done so many problems for you. You just need to go through and practice and ask questions if you get stuck. All right? Email me. Have a fabulous day. Bye.